All right, Honors Algebra 2, welcome to a quick video here for your remote learning / snow day, February 17th, 2021. There's Yogi, background. All right, so I emailed this to you. I'm going to give you a hard copy of this when I see you again. These are the first few pages. The new game plan, okay? So page 1 here. So what I recommend is just write these questions out. All right, so let's see if I can do a better job here. What we know from before, again, you have I emailed it to you, so it's the same questions. Oh, Yogi's here down with us. All right, hey, buddy. What we know from before. So we're going to take the second root. I put the 2 up there of 16x squared y to the 20th. The square root of 16 is 4. 2 goes into 12 6 times. 2 goes into 20 10 times. That's in section 6-4. That's what you're going to see on the 6-1 to 6-4 quiz. Easy peasy. We need to know how to break this down. If you got the TI 30 XS multi-view, type in or some Casios. We'll give you 5 root 2. Again, 50 is 25 and 2 or 10 and 5. 25 is 5 and 5. That pair, because I'm looking at that square root, I need a pair, breaks out of jail. 2 remains on the inside, 5 root 2. Square root of 12. 12 is 4 and 3, 6 and 2. You're going to get a pair of 2s and a 3. 2 breaks out of jail, root 3. All right, so what is different about 6-5 is that we're going to have leftovers. We're not going to have this clear jail break. So if I take the square root of 32x to the 8th, first off, I put that little 2 on the outside. All right, let's work with this number first. The square root of 32. It's 2 to the 5th. So I have 2 pairs of 2. They break out. 2 times 2 gives me 4 on the outside. But a 2 would remain on the inside. All right, so I would have 4. I'd leave a space for the x's, root 2. Okay, 2 is left over. On the inside. 2 goes in 8 4 times exactly. Okay, so the x's make a clean jailbreak. So I'd have 4 x to the 4th times the square root of 2. All right, let's take a look at number 2 here. I take the second root, the square root of 12 from above. 12 is 2 root 3. Okay, so you can give yourself a space. Put a 2, leave a space for x and y, root 3. 2 goes into 5. This is where we go back to elementary math. 2 times with 1 left over. You see, if I had the square root of x to the 5th, 4, 5, there's a partnership, there's a partnership, there's a poor x that would be left in. On the inside, okay, so I'd have x squared on the outside, x to the 1st on the inside. 2 goes into 6 3 times exactly with the y, so all the y's break out of jail like it happens in section 6-4. So we'll do number 3 together when I see you again, as we will do number 4 together. Take a look at 5. I'm now looking for the third root of 8. Well, the third root of 8 is exactly 2. All right. 3 goes into x, or 4. 3 goes into 4 1 time with 1 left over. 3 goes into 17 5 times with 2 left over. So y squared would be on the inside. And make sure that this leftover is to the third root, not the second root. Make sure you have the same index there. It's got to be a 3, taking the cubed root. Make sure that's a 3. Some folks lose 10% on a quiz because they forget that, or a 10th or whatever, I'll take off. All right, so let's go then to page 2. Take a look at some more of these examples. Second root of 72, doesn't matter how you break it up. You're going to have a pair of 3s and a pair of 2s. 3 times 2 gives you 6 on the outside, and that 2 would stay on the inside. 2 goes into 9 4 times, so x to the 4th, and you'd have an x left over. 2 goes into 5 2 times. Y to the 2nd breaks out, and you'd have a y on the inside left over. All right. The second root of 75. 75 is 25 and 3. 25 is 5 and 5. So 5 breaks out. 3 stays on the inside. 2 goes into 10 5 times exactly. 2 goes into 17 8 times with 1 left over. Square root of 24. 6 and 4. 6 is 3 and 2. 4 is 2 and 2. So 2 breaks out of jail. 3 times 2, which is 6, stays on the inside. 2 goes into 7 3 times exactly with 1 left over. 2 goes into 13 6 times exactly with 1 left over. All right? The leftovers stay inside the radical. So, folks, if I have the square root of 5 times the square root of 8, that's just the square root of 5 times 8 because I'm taking the same root, which is the square root of 40, which is 2 root 10. So that's the name of the game here. I'm taking the second root of both. So 32 times 2 is 64. X to the 5th times x to the 7th. Add the exponents. X to the 12th. Y to the 3rd times y to the 2nd is y to the 5th. Add the exponents. So now I'm taking the square root of 64, which is 8. 2 goes into 12 6 times exactly. 2 goes into 5 twice with 1 left over. The only thing that remains in radical jail is that y. We'll do 14 in class. Let's go to 15 here. Again, I just multiply the numbers on the outside. 3 times 4 is 12. Then I have x to the 1st times x to the 3rd. Cool. That's x to the 1st times x to the 2nd is x to the 3rd. Y to the 2nd times y to the 7th is y to the 9th. 2 goes into 3 one time. 2 goes into 9 4 times. 2 goes into 3 one time with 1 left over. 2 goes into 9 4 times with 1 left over. All right. Now, this is a not easy section. I'll describe it as. This is an involved section. All right, so 16, same deal here. 6 times 4 is 24, but then I have this 3 times 24. That's 72. X to the 1st times x to the 1st is x squared. Y times y to the 3rd is y to the 4th. Well, the x's and y's break out of radical jail. Again, you have an imaginary taking the second root there. 2 goes into 2 one time exactly. 2 goes into 4 twice exactly. Here's what's going to happen. So 72 is going to break down to be 6 root 2. You're going to have a pair of 3's and a pair of 2's that break out. So 3 times 2 gives you 6, which is immediately going to multiply with that 24. Again, this pair of 3 times this 2, that's 6, and immediately it's going to multiply with 24 to give you 144 on the outside. The only thing that remains in radical jail is this 2. All right. On 17. 5 and 3 gives you 15. 2 times 8 gives you 16 on the inside. X to the 1st times x to the 3rd is x to the 4th. The square root of 16 is 4, so 4 busts out of jail and multiplies with 15, give you 60. We're going to have a jailbreak here because 2 goes into 4 twice exactly. Nothing is on the inside, or remains on the inside of the radical. Folks, this is where the TI-30XS multi-view or some Casios really help out because you can type in square root of 32 gives you 4 root 2. Type in square root of 27 gives you 3 root 3. Type in the square root of 75 gives you 5 root 3. You can maybe type it all in together and it might give you this 4 root 2 plus 5 root 3 or 8 root 3. Anyway, if not, you break up the square root of 32. Pair of 2's multiply to give you 4 root 2 plus 27. It's 3 3's. That busts out, that stay on the inside, 3 root 3. 75 is going to be 5 root 3. I can add 3 root 3 and 5 root 3 to give me 8 root 3. All right, by now we should know how to break down radicals and how I'm getting 4 root 3, 3 root 3, and 5 root 3. 21, let's talk about this. We're going to break down root 12. It's going to be 2 root 3, but I got to take this 2 and multiply it by the 9 on the outside, so that is 18 root 3 plus 32, root 32 is going to have a pair of 2's that break out of radical jail. So that's going to be 4, which is going to multiply with 5 to give me 20. And that 2 stays on the inside. Minus 72 is a pair of 3, and 2 gives me 6 root 2. 20 root 2 minus 6 root 2 is 14 root 2. All right. I'm going to multiply with the radicals. What? So first outer, inner, last. All right, on 24 here. 4 times 3 root 2. I can multiply the 4 and the 3 together, and I attach the root 2. 4 times 3 root 5. I can do 4 times 3. That's 12. Attach to root 5. Here, 2 root 5 times 3 root 2. 2 times 3 gives me 6. Root 5 times root 2 gives me root 10. That's the first time we're seeing it here. 2 times 3 gives me 6. Folks, you have root 5 times root 5. Well, that's the square root of 25, which is 5. When you have a root that is being multiplied by itself, the square root just gets eliminated, and that number falls out. So it's going to be 5. 6 times 5 is 30. And that would be my answer. None of those are like terms. They don't have the same root. Square root of 2, square root of 5, square root of 10, and then 30, all different. 25 and 26, you have conjugates, okay? Same two terms, just opposite signs. So I can do the first and the last part of FOIL. Root 3 times root 3 is root 9, which is 3, minus root 5 times root 5 is the square root of 25, which is 5. 3 minus 5 is negative 2. It's nice to multiply with conjugates. So we're going to use that in a second. Conjugates again. 8 root 5, 8 root 5, 6 root 3, 6 root 3, minus, plus. So 8 root 5 times 8 root 5 is going to be 8 times 8, which is 64. Root 5 times root 5 is 5, minus 6 times 6 is 36. Root 3 times root 3 is 3. 320 minus 108, 212. So 27 through 30, sometimes some of the harder ones. Again, this section is not particularly easy. So if I want to get rid of a root or I in the denominator, I need to multiply by conjugate. So the conjugate of root 5 minus root 3 is root 5 plus root 3. We'll multiply top and bottom by that. Well, the bottom is going to be easy. It's just going to be 5 minus 3, which is 2. The top is going to be root 10 plus root 6. And it's not root 5 over root 3. There's nothing that breaks out of those radical GOs for root 10 and root 6, so it's just going to be that. If it's inside a root, I can't divide it by anything. What's the conjugate of root 2 plus 3? It's going to be root 2 minus 3. So the top's going to be 5 root 2 minus 15. The bottom's going to be 2, and I made a mistake here. Root 2 times root 2 is 2. 3 times a negative 3, though, is minus 9. So it's going to be minus 7. Okay? So I'm dividing by negatives, so this is going to be positive. That's going to be now negative. I'm going to get that negative out of the denominator. So just put a 7 down there. And now it looks better. All right, we'll talk about the other ones in class. Oh, man. Let's talk about these. So when I'm dividing two things with inner roots, I can make it as, I can just go backwards and say this was root 5x divided by root 8y. Okay? So I can multiply the top and bottom by root 8y. I can get rid of that root. A root times itself. The numbers just, and variables just fall out. Root 5x times root 8y is 40 xy inside the square root. I'm breaking down 40. 40 is going to be 2 root 10. The x and the y don't break out because 2 goes into 1, no times. 2 goes into 1, no times. So I can divide these both by 2, and that would be my simplified answer. I have no root in the denominator, and that's what we're really trying to avoid, no root in a denominator. We see that more plainly here. So multiply top and bottom by the square root of 5y to the third. Multiply top and bottom by that denominator. I have 6 times 5, which is 30. X squared, y to the third up top. Square root of 30 is just the square root of 30. It's got no pairs. 2 goes into 2 one time. 2 goes into 3 one time with 1 left over. Y's cancel. So you'd have a y squared up or down below. You'd have x times the square root of 30y up top. All right, last one we're going to do in this video. Do the other ones in class while we're reviewing for your quiz next time I see you, which is hopefully tomorrow, Thursday. All right, the third root of 48. So I'm not looking for pairs. I'm looking for triplets. All right. So 48 is 8 and 6, 8's 4 and 2, 4 is 2 and 2. There is a triplet. All right, so it's going to be 2 times the cubed root of 2 times 3, 6. 3 goes into 5 one time with 2 left over. 3 goes into 11 3 times with 2 left over. 3 goes into 6 twice. All right, we will finish this up when I see you again. This is Yak Math Videos signing out.